Now let's go ahead and do some comparison checks. Here I have 4 sets, A underscore, B, and C. Now obviously we can check for the equality, so I could do something like this. Does A equal B? And in that case, A is undefined. That is because I have not ran this cell again. Now let me check. This should return false. However, A does equal the A minus because they contain both the same values. Also, because this is an unordered list, it doesn't really matter what the order of the items here is. They should still, even if I execute it again, they should still be equal. Obviously, if I check is A underscore, are they identical? Then we get back false. Okay, so let's just ignore that for now and let's stick with the normal comparisons. We could also check, are they not equal? So does A not equal B? And if I'm gonna put 2 in the same time, just keep in mind when you put it this way, you're only printing out, or the terminal here, or the console, or whatever the interactive Python kernel that we're using is only going to be returning the value of whatever the last one is. So if you want to see both at the same time, you're going to need to wrap them both in print statements. Okay, so now if I run this, here we go. Both of these are true. A does equal A minus or A underscore, and A does not equal B. Now these are the easy ones, but let's talk about supersets and subsets and all of that fun stuff. Now, proper subsets are when you have all the elements from one set contained in another, yet they are not equal. So let me show you what that means. C is a proper subset of A. That is that C has 2 and 3, which are both elements that are contained in A. However, they are not equal. They're not exactly the same, right? So in that case, this should return true. Also, A is a proper subset of B. That is, B contains all the elements that we have in A, and they are not equal, right? So this is what we call a proper subset. Now, a regular subset or just subset basically means that one set contains all the elements in the other, and they can be equal. So in that case, technically A and A underscore are subset of each other. That is, A contains all the elements in A minus or A underscore, and they are exactly equal. If I try to check if they are proper subset, we should get back false. That is because they are equal. And we also have the same thing for superset. So we could say that B is a superset of A. That is, B contains everything that is in A, and they are not equal. So in this case, this is a proper superset. Also, A is a proper superset of C. That is, A contains everything that is in C, and they are not equal. So because I'm doing both at the same time, let me print. There we go. And similar to the set math that we've done, we could also use some operators for that, or functions for that. Now we only have methods for is subset or is superset in the named method. So we could do something like this: print C is subset of A, which should return true. That's basically what we're just checking for, but we cannot check if it's just a regular subset or a proper subset. We could also do print is B is superset of A, and that should work. Again, it only works with improper superset, not with proper superset.